Now we are going to deal with the fourth rule, that is fifth rule. We are going to deal now with the rule 5, which is the chain rule. This is actually a very important rule. Rule 5, which is the chain rule. This is also called at times outside inside rule. Outside to inside rule, right? So what I'm going to do is simply I'm going to solve a couple of questions, and you'll have to observe my pattern, and if you get my pattern of solving these questions, these couple of examples, then you'll get to know how to use this chain rule, right? For example, I'm starting with a couple of examples like let's say y is equal to sine x. If I differentiate it, I'll get cos x. Example 2. If I write sine x square, if I'm going to write anything other than x, then I'll put that thing in brackets, right? For example, here it was like sine only x, but here it is sine x square. So I'm just putting this x square within the brackets. Now I'll read it as sine bracket. Now if I'm asked to differentiate above y is equal to sine x squared, then what I'll do is I'll simply follow outside to inside rule approach, right? What I'm seeing outside is simply sine of small bracket. So sine of small bracket will be differentiated as simply cos of small bracket. Now after solving this sine, I'll go inside and see this is x square, so which will get differentiated as 2x. So my answer is simply 2x cos x square. In third example, let's say I'm given y is equal to sine x squared to the power 3. Then what I'll get is I'll if I am asked to differentiate, then what I see most outside is this power, and I'll read it as I said. If anything else is written except x, then I'll put that in small brackets. That's why I've put this x square within these small brackets. Now I'll read it as big brackets cube, the cube of big bracket. So I know that x cube is differentiated as 3x square. X cube is differentiated as 3x square. Similarly, this bracket cube will get differentiated as 3 big bracket 3 minus 1, that is 3 bracket square, and I'll write the things as it is within the bracket. So I have solved this power 3. Now I'll multiply in the second step, which is to differentiate this sign. Most outside I saw this 3. Now I'll see this sign of small bracket, and I'll differentiate it as cos of small bracket. Now this sign is also solved. Now I further go inside and see this small x square, and I'll differentiate it again by writing 2x. So my whole or my complete answer is 3 sine x square square cos x square into 2x. So this is my answer. Let's take a couple of more examples. Like for example, let's say I'm given sine of root x. Y is equal to sine of root x. As I said, if I find anything else written, then written here except x, then I'll put that in bracket. So if I differentiate, I'll see at first sine of small bracket and I'll differentiate it as cos of small bracket. Now this sine is solved. I'll go to this root x and I'll differentiate it. I know this that the differentiation of root x is 1 by 2 root x. So I get this result. Example 5. Let's say if I am given sec 2x plus 3 and x square y is equal to this. Now if I am asked to differentiate, then what I'll do is I'll at first see this part 2, big brackets part 2. I'll solve it as I do differentiation of x square as 2x. So I'll differentiate this bracket square as 2 bracket. So 2 sec 2x plus 3. So this part 2 is solved. Now I move inside and see this sec of small bracket. So the differentiation of sec of small bracket will be sec of small bracket tan of small bracket. Now the sec is also solved. I further move inside and I see this 2x plus 3 and I put this multiplication sign and I'll differentiate this 2x plus 3, and the differentiation of 2x plus 3 will be, for 2x it is 2 and for plus 3 it is 0. So I am putting here only this 2. So this is my answer. Let's take one more example. For example, if I am given, let's say 2x plus 1 to the power 5, and if I am asked to differentiate this, then I see that this is small bracket to the power 5. I'll differentiate it as by reading it as 5 power of bracket. So I'll write it as 5 2x plus 1 to the power 5 minus 1, that is 4. And now I move inside to see this 2x plus 1 and I'll differentiate it as to be 2. So this way we can move from outside, we move to inside and differentiate each thing, and thus we get the final result of differentiation.